In this video, we begin to look at how to work with integrals that involve ln of x in some way. It may not necessarily have ln of x as uh, an actual part of the integral, but it will be an integral that maybe results in the ln of something. So first things first, recall, or from the notes, that the integral of 1 over u du is the natural log of the absolute value of u plus a constant. So let's use that now on our first integral here. We have the integral of 5x over x squared plus 1 dx. Integral of 5x over x squared plus 1 dx. So first things first here, we don't really see, like many of our problems before, where we had a quantity raised to a power or something inside of a sine or a cosine function, where we were able to try to do substitution. So when that happens, one of the things you can try is to let u be the bottom. Let u be the bottom. And then that'll turn this into a 1 over u problem, which might result then into a natural log. So we look at that as an attempt. And it turns out when we do that and differentiate, we get 2x dx. So to carry the substitution through, we need to have a 2x dx, 2x to go with our dx. Well, if we look at what we actually have a 5x. So we have the x that we need. That's the important part in this substitution process. The 5 can just come out front because it's just a constant. We have 1 over x squared. Hold on. Whole bunch of stuff just went crazy there. So we have 1 over x squared plus 1, and then times 2x dx. All right, we need a 2. So I pulled a 2 out of nowhere and put it inside. So on the outside, I have to divide by 2. Now this is set up as 1 over u and du. So we can go ahead and rewrite 5 halves integral 1 over u du. Integral of 1 over u is just natural log, absolute value of u. And then to finish the problem off, we just replace u with what it is equal to, which in this case is x squared plus 1. So we get 5 halves times the natural log of the absolute value of x squared plus 1, and then plus a constant, of course. Now, one last thing here. When we do these, we need the absolute value there to start. But if we have something like x squared plus 1 that we know is always going to be positive, then we can actually remove the absolute value and rewrite this as ln of the quantity x squared plus 1 plus a constant, because the absolute value is actually redundant there, because x squared plus 1 is always positive. And so there we have our first integral involving the natural log. It was one that ended up being in the form 1 over u du.